Thanks again, everyone, for being with us today. We have a lot of questions. Um, I'm so excited to hear all these questions from you all. We have over 1,000 folks online right now, and this is our first time ever teaching a hyperspectral training. So I can imagine there are a lot of questions because it is a unique data set. So we do have time. We will get through as many questions as we can, as many questions as I can answer. And what you're seeing now is a question and answer session document where we have brought over many of the questions that you all have asked in the Q&A today. And I did want to mention that we will make this Q&A document available within about a week after each session. So we've included a lot of links here to some papers and more information. So you'll be able to access this Q&A document at a later date. So do please check back for that as well. I also wanted to mention we do often get a lot of questions about the homework, and the homework will be available during the last session. So it won't be available for another couple of weeks, but you will have 2 weeks to complete that homework, and it will be a Google form that you can fill out directly online. Okay, great. So we will go ahead and jump right into the Q&A here. If we don't get to your question today, we might cover it in the next 2 sessions, but you can also email us at our email addresses shown here. And again, we will keep this included on the Q&A document for your reference as well. Okay, jumping right in. The first question is it possible to measure nitrate concentrations in the agricultural fields from hyperspectral imagery? This is a really great question. Was not something I was familiar with, but I don't believe that hyperspectral data can be used to measure nitrogen directly, but it can measure chlorophyll really well. And the chlorophyll concentrations can be used as a proxy for nitrogen concentrations in many different agricultural crops. And so here's a little excerpt from an abstract from one study that measured nitrogen deficiency using the correlation with the cotton leaf chlorophyll. And so you could see they measured chlorophyll at 807.6 nanometers. It's very specific because they had the hyperspectral data there, and used that correlation analysis to identify deficiency in nitrogen. There's another link to a paper that identifies research that was done monitoring soil nitrogen with ground-based data and hyperspectral data. And this was done in apple orchards. And I'm not sure how successful this research was, but you can take a look at that link there for more information. Question 2, we had a lot of questions about eco-stress, and I'll go through them here, but we do include the link to the eco-stress lightning session that we had a little over a year ago now. So do please watch that recording for more information. It's about an hour-long session, and we have researchers who were involved in the mission concept, as well as a guest speaker from the LPDAC that talks about how to access data and display those data. So we'll include that link here, but do please check that out for more info on eco-stress. The question is, what does the asterisk on eco-stress mean? And we included eco-stress because it's this very unique sensor, but it's the optical portion of eco-stress is not really considered a hyperspectral sensor. It's considered a multispectral sensor. And we included it because it has been used to identify features for mission deployment that will be used to benefit hyperspectral missions as well. So it's really useful in that way. So we included a little asterisk there because we don't see the 200 plus bands of optical data from ecostress, but it is really important as a precursor to many of these larger missions that NASA is developing that may be on board the ISS or may be similarly designed. So, okay, question 3. Can hyperspectral data be used for crop monitoring and crop type classification? If yes, please explain how. And yes, that is one of the prominent applications of hyperspectral imagery. We are going to cover that extensively in our case study example for next week. It's actually the first case study example that we provide for a very large study that was done over many different crop types in the US. And the hyperspectral data was used to differentiate various peaks within the with different ranges, wavelength ranges for these different crop types. So stay tuned and come back with us next week and we'll talk much more about that example. Okay, the next question. Are hyperspectral data available via Google Earth Engine? The answer to that is yes. There are a limited amount of hyperspectral data available, primarily from EO1 Hyperion at a limited spatial coverage. So we'll talk about Hyperion a lot through this series. It's one of the most prominent hyperspectral sensors. And we've also noted here that you can access hyperspectral data from NASA and the USGS portals, and then you can add it to Google Earth Engine as an asset. So if you're familiar with that, you can use the data within the Google Earth Engine tools. Also want to mention that the developers of Earth Engine are constantly updating their data collections. And if you become if you register for an account, I believe you can access some user forums where you can vote on data that you want included in Earth Engine. And I don't know how the process works behind the scenes, but I think if certain data types get many votes, they may consider including those data within their collections. So I know we have done it for some other type of data that we've been interested in using. I also want to mention that during sessions 2 and 3 of this training, we will have demonstrations on how to access data, hyperspectral data. And we will also, our next training that we hope to provide will be specifically on land applications using Google Earth Engine. So do please check back in a few months on the RSET website for that training as well. We're really excited. It's a great tool. Okay, question 5. One constraint on multispectral bands are the atmospheric windows where the signal can or can't get through. The curves shown for hyperspectral seem to ignore those windows. Is hyperspectral also subject to those constraints? Yes, actually, hyperspectral data are still subject to the constraints of atmospheric windows. We cover atmospheric windows in our introduction to remote sensing training, and also any kind of optical data are subjected to those atmospheric windows. So these are essentially areas within the electromagnetic spectrum that allow the sensors to pick up data, that allow the reflected energy to pass through the atmosphere and be collected by the sensor. And there are certain portions within the electromagnetic spectrum where that doesn't occur very readily. But thankfully, mostly for the visible and near infrared wavelengths, those atmospheric windows are there. But yes, I also provided a nice short explanation of what an atmospheric window is there on the Q&A as well. Okay, next question, 6, is HYCO data available for India, and is it available to researchers? HYCO data, as we mentioned, is only available for certain coastal areas, but it is available for some coastal areas in India. It's readily available through the NASA Ocean Color Web data access platform. And as I mentioned, the next two sessions, the second session will cover land applications, the third session will cover ocean applications, and we'll actually be doing a demonstration on how to access data in session 3, going over the NASA Ocean Color Web and talking a little bit more about HYGO data, I believe. So stay tuned. Okay, question 7. How are clouds removed in hyperspectral images? So clouds are an issue in much the same way they are for any kind of optical remote sensing. So this is an issue with multispectral data like Landsat, MODIS, the very common ones that you all know. So clouds have to be removed. There are techniques such as cloud masking that could be used to remove those pixels. As we'll discuss during the demonstration, we generally recommend when you're searching for data to use a threshold of about 20% cloud cover, because you're really not going to be able to use those scenes in which clouds are very predominantly present, at least with optical data. You'll need something like radar data to penetrate those clouds. So we have that same issue here with hyperspectral data. Okay, question 8. This is a great question. So what did you use to make the HYCO visualization with the RGB slider? And that could be a really useful teaching tool. We love that animation too. We included the link there to the HYCO animation, and this was created by the team, the Ocean Color team at NASA Goddard. So we can't take credit for that one, even though it's very, very cool. So we've included the link to that visualization. It also has a little bit more information of how that was created on that website there. Okay. Question 9. My question is, are there rays emitted by different remote sensing satellites harmful for delicate coral reefs during the scan? No, so with all kinds of passive optical remote sensing data, there is no energy being emitted onto the ground. The only thing that those sensors are collecting are reflected imagery from the whatever feature we have on the ground. So there's no harm that could be done to coral reefs because the only data we're obtaining are the reflected wavelengths that the coral is emitting as it's living. So great. Okay. Question 10. And here's a few eco-stress questions. I think this is probably while we were going over the eco-stress slides. But does eco-stress have information for South America? There are a couple locations where eco-stress data are available in South America. There's this great website within the eco-stress site that's a map of where data are collected. As we mentioned, EcoStress is on board the International Space Station, and it only collects data at very specific targets. Most of those targets are aligned with some kind of ground-based network that had been in place when they were developing the sensor. So you could check out that map for the locations of those data. And this was, again, a shorter mission that's still in operation, but on board the ISS was only planned for a short period of time, but we're going to keep it going for as long as we can because it has some really useful data. Question 11. Eco-stress is hyperspectral or thermal? Is it affected by cloud cover? So this is similar to the question that we had previously. It essentially has multispectral optical data and thermal data. And yes, it is still affected by cloud cover. Any kind of optical sensor is going to be affected by cloud cover. And we've also included the link to the very specific technical information about ecostress. And on that website, it has the different bands of ecostress and their wavelength ranges. So you can see all that information there. Question 12, can ecostress measure soil moisture? Ecostress was primarily designed, and as far as I understand it, is being used for evapotranspiration, or ET, not necessarily soil moisture. The SMAP sensor, the soil moisture active passive sensor, is another one that can be used for mapping soil moisture. It is a little bit more coarse in resolution, but that's another one to check out if you're interested in soil moisture. And then here I've included the link to the lightning session for ecostress, because I know we had a lot of questions about that. It is a very, very cool instrument. It has a lot of useful information. So, okay, question 13. What kind of research is done with HYCO? Great question. So HYCO was designed for coastal ecosystem applications. It's been used a lot for coral reef analysis and shallow water coastal ecosystem. This is another sensor on board the ISS, the International Space Station. And again, with many of these smaller sort of missions, they're designed for particular use, and that particular use and region was mostly based on the needs of the user, and that's why the data are limited primarily to regions, coral reef regions. And again, we'll discuss this in more depth during session 3 as well. We'll come back and talk about HYCO again. Question 14 is a really great question that I think came through before we got to the end of the training, where we talked a little bit about this. So the question is, the large number and continuous spectral bands in a hyperspectral system cause redundant spectral information between neighboring bands. How to decide which bands are more relevant for a particular application? That's a really great question, and is very specific to the application that you are interested in. Because the bands are so closely spaced together, there's often a high amount of correlation among those bands that are next to one another within the electromagnetic spectrum. So there are many techniques for disaggregating those correlations. Principal component analysis is probably the primary one, where you can essentially identify the correlation among the bands. And so what you would need to decide as the user of the data is which bands are relevant for whatever application I'm interested in. So if, for example, you had 2 bands that are highly correlated, you might decide which of those bands is presenting you with more useful information. Is there higher reflectance in one or the other band in the target that you're interested in viewing, and does that provide any additional information for you? That type of analysis is beyond the scope of this training. This is really just an introductory training to introduce you to the data. But there's a lot of research out there that's been done on PCA. Also, on a related note, because of this high spectral resolution, there can be a lot of noise in the data as well. So your signal to noise ratio can really affect the ability to use those data. So the minimum noise fraction is one technique that can be used to reduce the level of noise in the data. Many of these techniques need to be applied on some sort of geospatial processing software that is not freely available, such as Envy. So do keep that in mind. But that's a great question. Yeah. Okay. Question 15. Can hyperspectral be used to determine bathymetry? Yes, in some cases. Again, we'll talk about this during session 3, but it can be used to analyze bathymetry in shallow water, shallow clear water. Here's a paper, we've listed a paper that used hyperspectral data in Australia to estimate bathymetry. And it is limited because of the very complicated interactions that data have with water and with the surface properties of, say, a lake or ocean. So we'll talk about that much more on session 3, but I would say yes in a limited capacity. So question 16. Good question. Yeah, if hyperspectral data is so granular and valuable, why are missions not operating at scale? Are the costs too high? So there are a lot of factors that we mentioned in the training that contribute to the inability of global hyperspectral missions to take place. Yes, the costs are high. The data sets are very large. So if you have 220 bands of optical data at 30-meter spatial resolution, you can imagine that those data sets are huge. And storing and cataloging those takes a lot of effort and resources. And also the data are more difficult to process and analyze. It's a heavier lift for somebody who is just getting started with remote sensing to analyze and process Hyperion data versus analyzing and processing Landsat data. So there are many factors that come into play. But you will notice that we mentioned 3 new satellite missions that are in the works, PACE, SBG, and Glimmer. Those will, at least PACE and SBG, I believe, will be global. So there's interest out there, and the need has been recognized through the decadal survey, and we're working on it. But it's a great question. And you can get involved in those efforts as well as they develop those instruments and get those launched. Okay. Next question, is Prisma data freely available? If yes, where can I find it? The data were recently made available, and I believe Prisma data are available via the Italian Space Agency. And there's an article on the SBG website actually that talks about the release of Prisma data, and there's a website we've listed there as well. I do believe you need to register or maybe fill out some forms to access those data, but it seems like those are now freely available. Okay. Next question, 18. Is PACE 5-meter spatial resolution? Oh, so I think the confusion there is between spectral and spatial resolution. So PACE has 5-nanometer spectral resolution. So that means that the bands are spaced 5 nanometers apart. But the spatial resolution is 1 kilometer. The other sensors within PACE will, so that was for the ocean color instrument, which is one we mentioned. There are other sensors have different spectral and spatial resolutions, and we've included the link to details on PACE there as well. Yeah, 5-meter spatial resolution would be quite quite great, but very difficult to achieve. Okay, question 19. What is the maximum limit and how of the number of bands in hyperspectral? Actually, is there a limit? Yes. If yes, what does it depend on? So the number of bands is going to really depend on how closely spaced the bands are together, so their spectral resolution, and the wavelength range that the data cover. So we discussed this a little bit more in depth during the first part of the session, but I've not seen more than about 220 bands. So there's definitely a limit if you are looking at a particular wavelength range. Generally, the hyperspectral data are available in the visible and near infrared. Some of them, I believe, maybe go into the shortwave infrared, but it really just depends on how far apart those are spaced. But I'm not sure if there's any sensors that have more than 220. That sort of seems like the limit I've seen. Okay. Question 20. In the Himalayan mountain vegetated cover area, can we differentiate sedimentary rocks through hyperspectral imagery? That's a good question. So the data are optical, as we've discussed. So optical remote sensing data only acquires information that's reflected from the top of the ground surface. So if you have vegetation covering rock, you will only get the spectral reflectance from the vegetation. In order to assess different rock types, it would need to be bare ground. So that's the limitation there. You're not getting anything penetrating through vegetation. Question 21. Which data are and will be freely available? Good question. So there are multiple different online platforms, and various data are available for freely available. So HyGo, Coral, Avarice, EO1, Hyperion are all available online. NASA data are always going to be freely available. In some cases, there may be a registration process or request for access to those data. Data from those sensors that we mentioned are available on the NASA Ocean Color web, NASA Earth Data, Earth Explorer, and some other data access platforms. And again, we'll talk about this in more depth in the next two sessions. But it's a great question because many of the airborne campaigns, the data are not easily accessible in some cases. But all the NASA data are available through the various websites we mentioned. Question 22, for SBG, when you see it launched thermal bands, what would be the spatial resolution? I don't think that's been decided. I suggest becoming involved with the SBG applications community. There is another event coming up in early February, and we've included the link to the SBG website in the presentation materials. So do get involved with that. But I think they have a range for the spectral resolution, but I don't think and the temporal resolution, but I don't think they've clearly identified what the spatial resolution will be. I could be wrong on that, but do please check the SBG website. The mission is still in development, so I don't think all of these features have been totally decided. Okay, moving on to question 23. Thank you. You've said that hyperspectral remote sensor captures more than 3 visible bands, RBG, as compared to 3 RBG for multispectral. Can you elaborate more on this? Yeah, so we talked about this quite a bit during the beginning of the session. The benefit of hyperspectral data is the ability to monitor spectral reflectance among a contiguous wavelength range with many, many bands. So a multispectral sensor, for example, might have 10 bands within the visible and near infrared portion, whereas a hyperspectral sensor would have 200 bands. And I'm just throwing out some relative numbers here. But that allows the sensor to capture more of the variability within the electromagnetic spectrum. So you might, for example, when you're looking at Landsat, you will get one value within the green range. Whereas if you're using a hyperspectral sensor, you might have 20 bands within the green range or near infrared range. And that's going to allow you to distinguish very subtle differences in reflectance from whatever target it is that you are analyzing. Yeah. Question 24 is really interesting, and it's something I had not thought of before. Have there been any initiatives to observe plastic waste and plastic litter in water and on the surface of the soil? I do believe there's been some work looking at plastic pollution in the oceans using hyperspectral data, and we included a link to one article there. But I'm not sure how extensive this research area is in terms of the use of hyperspectral data. It's not an area I'm very familiar with, but a really great question, and I think a useful application.
And Amber, this is one I can elaborate a little bit more.
Oh, great! Yeah, please do.
Yeah. So during the coastal webinar that we did last year, we covered some of, and during session 3 in particular, we covered some of the uses of remote sensing for marine debris. And there hasn't been that many so far, that many papers out there using particularly satellite-based or airborne-based data, hyperspectral data for marine debris or plastic litter, as the question says in this case. But people have used spectroradiometers, field spectroradiometers, to separate different types of plastics or just marine debris in coastal and areas in particular, that just to use them as a baseline for constructing a spectral library to eventually use that library with satellite or airborne images. So I encourage the person who did this question to go back to our coastal webinar, session 3 in particular, and we covered some of this. And there's I think a couple of papers that we also mentioned on this regard. Thanks, Amber.
Thank you, Juan. Appreciate that. Yeah, feel free to jump in at any point. I'm not providing all the information needed, so that's great. You are the ocean resident expert here. Okay, a few more questions. We have about 8 more minutes for questions, so we'll get to as many more as we can here in this session. The next question, why does the hyperspectral data come with medium coarse spatial resolution? While I was mapping urban land use and land cover, it was very difficult to identify land classes using a 30-meter pixel size. How would you be able to map vegetation or urban features accurately unless you want to map something for a broader scale? That's a great question, and that really goes back to the way in which these missions are designed. There is always a trade-off between spatial, temporal, and spectral resolution. So when the engineers are designing these systems, they have to make some decisions on what they can provide. There's no system out there that can provide very high spectral, spatial, and temporal resolution all together. So with Hyperion, that was sort of a trade-off that was made. And 30 meters, you're right, it's difficult to identify small features on the ground. And I would suggest using different types of data. So there are other commercial satellites available that may have an increased spatial resolution. Also, NASA, as it is designed as a public service, cannot compete with commercial businesses who are creating satellite systems that may have higher spatial resolution. So there's also a limitation there with how far NASA can go in terms of providing really high spatial resolution data. Other data that might be useful are drone data, which you can fly on your own. And there are a lot of researchers out there who are using drone information. However, much of the drone data are multispectral, RGB, and sometimes near infrared or red edge with the drone data as well. So you just have to take all of that into consideration when deciding on the data that you're using and for what application you're using. There's always going to be a trade-off there, but it's a great question. Question 26. To my knowledge, ENVI is one powerful image processing for hyperspectral data, but it's not free. What are free but powerful image processing software for hyperspectral data? That's a great question. One of the reasons why in sessions 2 and 3 we're going to be using well, QGIS for session 2 for sure, because yes, ENVI is a commercial software. AirDOS Imagine is another commercial software that is not free, that is often used for more advanced remote sensing applications. We will show NASA CDAS, which is another free option to use. We'll be showing that one in part 3. So we'll be showing QGIS in part 2, CDAS in part 3, but there really are some limitations, particularly with hyperspectral data, because most of the hyperspectral data need to be processed to a level by the user. Most of those data are not processed to spectral reflectance, as you can obtain with something like your Landsat and MODIS and VIIRS. So that does require the user to conduct this extra layer of processing that generally needs to be done in a commercial remote sensing software. There are some exceptions, but that is another really important limitation to consider. Question 27, sort of similar. Atmospheric correction must be applied even if it's level 2 data. Level 2 data are generally atmospherically corrected and are surface reflectance. However, many of the data available via hyperspectral sensors are only pre-processed to level 1. So that's where you get the radiance values. And as I mentioned, you as the user would need to go through that additional step. And that's not something we'll cover in this training. But that is one limitation to consider. Not a whole lot of the hyperspectral data have been processed to level 2 that I'm aware of. So, question 28, can a master student be part of PACE, SVG, and Glimmer? Certainly. One of the reasons why we wanted to highlight the upcoming missions is to get folks involved. So certainly, we've included a couple links there for how to get involved in those missions. And this includes researchers, this includes applied users, it includes a wide community. And I think it's a really great thing that NASA has been doing in a higher capacity, is including the users of the data in the mission development. And I think it's a really valuable part of mission development. So yes. Next question. Okay, let's maybe take two more and then we'll be done as we're approaching the end of the session here. So the question 29 is, considering the limitations in accessing hyperspectral data, what factors should one consider to access hyperspectral data for a particular study area? Malawi, South Africa. So the first step is to identify the extent of these missions. When you're searching for data, you can search for spatial, you can search based on a spatial extent in many of the data portals, and we'll show you this in Earth Explorer. But what you could do is identify your study region as a rectangular area or even a point of latitude and longitude, and then you can see what data are available there. I think that's probably the easiest approach. Or you can go to specific missions websites to see where those data are. But I think if you just go to one of the primary data portals like Earth Explorer, which is what we will demonstrate next week, you can always filter by area. Okay, the last question, and then what we'll do is we'll go through and answer the remaining questions outside of this time and post them online. So the last question we'll have today, I'm curious about AVERS data applications. Can you please cover more elaborately and also help me learn about providing more information? So yeah, AVERS has been used for air quality and wildfire smoke assessment applications. And this allows for the differentiation of different airborne pollutants that can capture specific pollutants tied to those types of events. I'm not sure if our health, so within RSET, we're the land and ecological forecasting team. We also have a health and air quality team. And so I would check out the other trainings that are conducted by our health and air quality team to see if they've covered any examples of AVERS. I'm not sure if they have. I will also mention that we are planning a wildfire training sometime this year that will cover, that we will have scientists within these different application areas coming together to cover sort of the full gamut of wildfire applications, and smoke will be included, pollution will be included in that. So I'm not sure if we'll cover AVERS in particular, but our health and air quality team, we will definitely cover smoke events tied to different types of wildfires. So do please check back within the next few months if you're interested in that training as well. All right, everyone. So thank you so much for being with us today, and for all your really great questions. We will get to and try to answer the remaining questions that you've provided here on this document. We will post this document within about a week or so after each session. You can email myself or my colleagues, Juan and Zach here, with our email addresses listed if you'd like more information, or if your question didn't quite get answered, but we will post these for access later on. So thanks again. Do please join us next week at the same time, where we will cover more case study examples of land applications of hyperspectral data and do a really nice demonstration of how to access some of these data. So thank you again. I hope you all enjoy the rest of your day, and we will see you next week.